Today, huh? What'd you say? No. Hardest working kid in here.
I saw him in my picture in my head. I'm not gonna walk around with one shoe on. And then I got no socks.
Okay, your test is on Friday. So the way that I tried to split it up, okay, today is going to be most of like the algebra stuff. Tomorrow will be mostly graphing. Okay? So take a look at your first page. Okay, you are finding the domain. Okay, we covered this week, the first week back. What do you do if you have a square root? Domain. What? No. What can you not take the square root of? Negative. So you take the middle, greater than or equal to 0. Remember? It's been a while. Okay, remember you can't square root negatives, so the stuff under that has to be positive or 0. So what do we do first? Yeah, plus 8. Okay, so then we have 2x greater than or equal to 8. Last step, divide by.
X is greater than or equal to 4.
Good. Now remember, here's what you're supposed to write. Okay, x within all real numbers, x greater than or equal to 4. That would be your domain. So remember that x are the numbers that, domain is the numbers that x is allowed to be, the set of numbers. There are a couple that are multiple choice, mostly not though. Okay, look at letter C. What's letter C's domain?
C. Oh, 3 is 3.
Nah. It's a polynomial. What number are you not allowed to square? None of them, right? Remember, for a polynomial, I can square whatever number I want. 3, I can square it. Pi, I can square it. 5, I can square it. So polynomials don't have any restrictions. It's all the numbers. Okay, so if it's a square root, you take the middle, greater than or equal to 0. What about for a fraction? What can you not divide by?
0.
So you take 12 minus 3x. What is it not allowed to equal, we said? 0. Because I can't divide by 0. So if I get a 0 on the bottom, that's a problem. So I'm going to minus my 12 across. So I have negative 3x cannot equal negative 12. Good. Divide by negative 3. X cannot equal 4.
The next one is just less than, right?
Now we remember. Okay, x within all real numbers, squiggle bracket, squiggle bracket. That would be your domain. Okay, also keep in mind that you have a review with all this crap on it, right? Okay, take a look at letter F. What do you do if it's a fraction square root combo?
You do a less than or greater than.
Good. It's a greater than only. Why is it not greater than or equal to? Because the fraction says it can't equal 0. The square root says greater than or equal to, but since I can't have equal to, it's only a greater than. Then you add your 4 across, plus, plus. Then remember, your full domain would be x within all real numbers, x greater than 4. So that means it's any real number as long as it's greater than 4. Got it? Good? Okay, go down to the next one. Okay, how do you find an inverse? This is what we just covered. Switch the x and y. Very good. And solve for y equals. So let's say that we're doing, y'all want to pick 2? C and F maybe? Okay, let's do C. So remember, I'm going to have 5y minus 3 squared plus 1 equals x. So I turn my x into a y, and then instead of a y equals, now it's an equals x. Okay, minus the 1 across. Good. Okay, y minus 3 squared, x minus 1. Then to get rid of a fraction, you times by the bottom. To get rid of a whole number, you multiply by a fraction. So if it's a 5, I got to put a 1/5 here, 1/5 here. Do not distribute, just leave it out in the front. And these guys are gone.
Square root. That's
Good.
square root.
So I have y minus 3 squared, 1/5 x minus 1. Next step, square root. Square root. Square root. Now, there's one thing that I do still want to see on your paper. When you take the square root, you should have a plus or minus in front, so don't forget about that.
That's the one thing I forgot to do.
Then plus 3.
And I messed up. Thanks a lot.
So dramatic. Okay, then the minus 3, to cross out the minus 3, I'm going to put a plus 3 here and a plus 3 here at the back. So my answer would be this guy right here. Okay? Y'all see that okay? Alright, letter F right below it. Okay, first thing I'm going to do is switch 1/4. Now it's a y minus 7 equals x.
That's when you multiply.
Times by 4, very good. Remember, if it's initially a fraction, you're timesing by a whole number. If it's originally a whole number, you're timesing by a fraction. Those cancel each other out. 4th and 4 cross out.
Then you square.
Good. Then I have my y minus 7 coming down, and I will square both sides. Now remember, when you square, keep the 4 in there too, because 4 and x were already together. They have to be squared together. So I have y minus 7 equals, my square root goes away, 4x is squared, then plus 7 plus 7. Good.
What to do with the fractions, all that.
Okay, do we need to do one more, or you guys think you got it? One more, you pick one.
Yeah, do one of the fractions. Do the whole the E. No,
Letter E, okay?
or B.
So first thing we're going to do is switch the x and y. So it'll be 2y minus 4 minus 1 equals x.
Yeah, you add the 1.
Okay, add the 1 first. Remember, and also let me talk about something real quick. Look at the one right next to this. Would you be able to minus that 4 across as your first step? Because it's inside. So look, if you have a number added or subtracted on the outside, that's the first to go. But if it's on the inside, you have to wait and get rid of the square root of the squared or whatever and then move it. Yes?
The 1 is the first thing to go, and then it's the 2?
And then the 2. That's a good point to make. So anything outside of the square root has to go before you can eliminate the square root. So I'm going to add my 1 across. So I have 2 root y minus 4. Then I have an x plus 1. Then I'll apply to get rid of a 2, a 1/2. Don't distribute. Use parentheses.
And then add the 4 over here.
Can't add the 4 over because why?
Square it.
Square and then add the 4 over. The minus 4 is inside. I have to wait. So I'm going to square here, square here. Now remember, if you end up with 2 sets of parentheses, oh well, who cares? Leave them there, okay? So I have y minus 4 from the middle, 1/2 x plus 1, and then I plus my 4 across, and you are done. So it'd be y, we'll rewrite it, but you don't have to if you don't want to. Up to you.
We should do B later.
Nah, you got that. Alright, turn the page when you're ready. We're going to just do a couple from each section. Okay, then also while I'm thinking about it, if you need to come to tutoring after school today, after school tomorrow, you can come during A lunch if you have A lunch. Just let me know. Okay, next one, slope of a line. Okay, we covered this, but you already covered it in Algebra 1. How do you find slope? There you go. Point slope form.
Ooh, the AX thing. No. Yeah. Yeah, that. Y minus y.
Yep. Now, you will have these formulas on the board, so you don't have to memorize them. I'll put them on the board for your test.
And then the other one is y and it's supposed to be.
Yep. Okay, so 3a says find the slope from 6, 2 and negative 2, 6. So the first thing I'm going to do is find the slope. That's m equals. This is x1, y1. This is x2, y2. So when I set up my points, it's going to be y2 minus y1. Which numbers do I use?
6 and negative
6 minus 2, and then x2 minus x1 would be negative 2 minus 6. Okay, then 6 minus 2 is 4 on the top. Negative 2 minus 6 is negative 8. Can that reduce? What's 4 out of 8 the same as?
1 over 4.
A half.
Well, half, yeah.
Yeah.
Why did you put a negative on the bottom one? Is it just a negative?
Well, you're doing y2
Y2
minus y1.
Yeah, on the y.
And then x2 is your negative 2
Yeah,
minus x1. Okay? So for 4b, remember you have two things to do. You find the slope, we already did that. Then you put it in point slope, but you just pick a point. So which point do we want to use? It doesn't matter.
6, 2.
Okay, we pick 6, 2. Does it matter if you pick the other one? Not at all. So I'm going to use this formula right here. So y minus y1, what's my y value? 2, so y minus 2 equals. Then I come to my m, which was negative a half. I just found it here. And then my x value is a 6, so it's x minus 6. Then let me also just remind you that whatever number you are putting in the parentheses, it should be the opposite of the x and the y value. So if this is a positive 6, I'm using a negative 6. If this had been a negative 2, I would have put a plus 2 here. Okay? From there, we're going to solve it. So negative 1/2 multiplied in. What's minus a half times x? Negative a half x, right? And then half times 6, positive or negative 3? Positive 3. Why positive? Good. Last step.
Add 2 and 1.
And then you're done. I'm going to write my answer over here, but my negative and positive 2's cross out. Negative a half x plus 5.
Oh,
Okay? Alright, problem 5 is very similar. You should be able to do it. Go down to problem 7, because I can't count apparently. Okay, problem 7, write the equation for the horizontal line. Horizontal line is a hoy or a vux. Okay, horizontal line is a hoy. Look at the next one. I want a vertical line. What's a vertical line? Vux. And remember, if it's horizontal or vertical, it's either x equals or y equals. For the hoy, which one is it? And what y value did both of my points have? 4, 1, 6, 1, then y equals 1. Number 8, I want a vertical line. Is that a y equals or an x equals? X equals. And your points better have the same x or it's not a vertical line. 4, 1, and 4, 6. So it's 4. You can also just look at the number that matches. That's another way for you to do it. If the x's match, you automatically know it's vertical. If the y's match, it's automatically horizontal. Okay? Alright, next one, you have just a little bit of domain and range from the graph. Okay, take a look at your graph number 9. We'll do that one. My vertical asymptote goes this way. Where is it? X equals what?
Negative 1.
Good. This is x equals negative 1. Remember, an asymptote is a line my graph cannot touch, right? Okay, where's my horizontal line?
3.
Okay, y equals 3. So we see our asymptotes. What is the domain then of the graph if it goes forever back here?
Infinity, right?
Okay, now, then here, it's going to keep going and going, but can it ever touch negative 1?
So wouldn't it be...
So you'll break it into 2 chunks.
Yeah.
So you'll go negative infinity to negative 1. Open or closed on negative 1? Open, because why? It never gets there, right? If it's an asymptote, I never actually touch that value. Okay, then I look at my other chunk. He gets really, really, really close to -1, but he never gets there. So open again. And then how far does he go to the right? Infinity. But remember, we are breaking it in parts because of the asymptote. Okay? Then for my range, I have to do the lowest it goes. How low does it go here? -infinity. And then it goes up, 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 up. And then when does it get stuck? Can't go past 3. So -infinity to 3. But then I have another chunk of the graph. This chunk goes all the way to infinity, but how low can it go? Where does it get stuck? At 3. So it'd be from 3 till infinity. So remember, asymptotes break your graph up into chunks where you'll have to use a union in the middle. Okay? Then last little thing on there, increasing and decreasing. Remember, increasing is a positive slope, which means that it's uphill. And then decreasing is a negative slope, which means that it's going downhill. So if I look at this graph, and let me also say one other thing, you have to look at it from the left to the right. So if I'm looking at this guy, I'm going from left to right. Increasing or decreasing? That's increasing. What about this part? They're both increasing. So it's increasing -infinity till infinity. Where is it decreasing? It's never going downhill. And now sometimes I'll see people that are like, well, wait, if I go this way, remember, you have to go to the right. Okay?
So for number 10,
So I'd put, hold on real quick, empty set, remember that? Okay, so I'm going to give you a second. I want you to try to do increasing and decreasing on this W. I'm not going to do the whole thing, but... Okay, highlight on the graph. Well, I guess you may not have a highlighter. Where is it going uphill? What parts?
At the top, but it's like...
So here I'm going down, doesn't count. Up, stop. Down, up. Those are your increasing. So what are the x's it was increasing on for this chunk? Let's just round it to whole numbers. So -1 till 1. Union. When else is it going uphill?
1 to...
That looks like, we'll round it to 3.
Yeah, 3.
So 3 till infinity. Okay, then for decreasing, okay, I'll do the decreasing chunks in red, or in orange, okay, but downhill, downhill. So I have 2 little pieces of the W that are going downhill. Okay, where's my first piece from?
Infinity is
-infinity till -1. Because remember, you're using your x's. And then my other little orange chunk where it was decreasing is from 1 till 3. And then I'm going to put down here rounding to whole numbers so you don't get confused. Okay, last page.
I remember
Y'all want to just do the domain and range while we're here? What's the domain?
Oh, it was all the numbers.
All real numbers, because look, I got arrows here. I got arrows here. So x within all real numbers or -infinity to infinity. Those are the same. Don't care which one you put. They're both good enough. What's the range? How low does it go? -3 till infinity. Open or closed on -3? Closed. Why was it open here? On this one? Because there was an asymptote. And remember, an asymptote means I never actually get to 3. When I come here, I got to 3 right here. And then I went up, and then I got to 3 again, right? So that's why that one is closed, is because I touched 3. Versus an asymptote, can't touch it. All right, last page. Do we want to review the step function, or y'all got it? Review it, okay? Look at your graph. Where is my first step? Give me the y value.
Okay, so -2.
Okay, so this one is -2. Now I'm just going to do all the steps first. So my orange step we'll say is -2. Okay, where's my, we'll say blue step?
Then
1.
1,
Okay, next step, how high is that one?
4,
4. And then how tall is my purple step?
7.
7. Okay, then what goes on the little line? That's the domain of that particular chunk. So if I'm looking at orange, here to here, what are my x's at the beginning and the end of the orange step? -8 to -5. Which one should be closed? -8. How do I show that it's closed on inequalities? You put in equal to. Good job. Now look at your one step. That's my blue step. What are my x's on either end? -5 till -2. And which one should be closed?
Yeah, 5.
-5. Yeah.
Can we just write it with brackets and parentheses?
You could do interval if you, we'll do the next one in interval just so you can see it. So if I was doing yellow, I'd start at -2, stop at 4. And then I'd make -2 a bracket, I'd make 4 open. Now typically you would not see that notation in a piecewise, but it's not wrong to do it. You could if you like it better. Okay? And then last little line chunk, my purple step is from 4 till 9. But either form is fine, either one is wrong. Okay, then for your domain, remember you only have to break it up if my graph never touches that value. So when I'm tracing across here at -8, I go all the way to -5 and it's open, but then what happens up here?
It's closed.
It's closed. So, was it never -5? No, it was -5 here. I don't have to break it up. Then I go all the way across till -2, it's open. But then I look up here, bam, they closed it. So I can keep going all the way across, open, but I have it closed at the same value, all the way across to here.
So -4.
-8 to 4. And you do not actually till 9, right? -8 to 9.
9.
Yeah, because you got to go to the end of this last one.
Oh, I don't say it's open.
Well, and it's open, so I'll use a parentheses on that side. So closed on -8, open on 9. But then remember, since it's a step function, you list the steps. And you don't do like a inequality thing for your range. So you would just say, y within all real numbers, what can y be? Only 4 numbers.
-2, 1, 4, 2.
Those are the only numbers that y is allowed to be. Okay, then we'll do D and F. What's f of -7? Well, where does -7 fit on my graph? Which step?
-2.
-7 fits on my orange step, which is at -2. Okay, what about f of 2? Well, I'd come over to 2. What step am I on if I'm at 2? Which color?
4.
You'd be on yellow, which is at 4. Okay, then let's say we want f of, let's do 9. What would f of 9 be?
Oh, undefined because it's no.
Very good. F of 9 is open. There's never a closed dot, so it's undefined. Okay, then this last one, we'll just go down the middle row. Okay, so look at number 13. Okay, you're going to do f of x minus g of x. Remember, you just kind of give both of them their own x. So what's f of x listed out for me?
3x squared
Minus g of x is...
a squared.
Now, I'm going to get that wrong, because why? Do you remember what you have to use for a minus? Yep. And the reason that that matters with a minus is that if I'm minusing x squared and minusing -4, that negative 4 switches to a plus. So I'd have 3x squared minus 5 minus x squared, but then a plus 4, and then combine like terms. What is 3x squared if I take an x squared away?
2x.
Okay, 2x squared. And then what's negative 5 plus 1?
What's the
Minus 1, yeah? Because it's a negative 5 and a plus 4. So I put my 3x squared minus x squared together. Then I put my minus 5 and my plus 1. Think about it. You borrowed $5, but you only paid me 4 of them back. Then you still owe me 1. Okay, number 16, g of 0. What do I do?
Plug in 0 first.
Plug in 0. So I'd have g of 0 equals 0 squared minus 4. What's 0 squared though? 0 times 0 is?
0.
What's 0 minus 4? You will get a calculator for your test. So if that part stresses you out, don't worry about that. Okay, look at number 19. F minus g of 0. I need f of 0 minus g of 0. Then I'll find both of those numbers, then I'll subtract them. Look at your f of 0. F is here. So f of 0, I'm going to write it up here, would have been 3 times 0 squared minus 5. But 0 squared is 0, and what's 0 times 3?
0.
Still 0. What's 0 minus 5? Negative 5. So f of 0 is negative 5, and g of 0 I just found. Yeah, right here, see it? G of 0 we found was negative 4. So if I have negative 5 minus negative 4, that's really a plus.
So it's negative 1.
Negative 1. Huh? Oh. Okay, next one, f minus g of x. Didn't we just do this? Yeah, we did skip it. Okay, and then last row, dang it. What is, this is a times, and this is a times. These freaking things. Okay, make both of those multiplies. Since we're skipping that one, let's do 23. F times g of x is f of x times g of x. What's f of x? 3x squared minus 5. And then what's g of x? X squared minus 4. Now, you should have already learned how to do this in, like, Algebra 1. You'll have to distribute. So what is 3x squared times x squared?
I was going to say cube, but
You said quad.
3x to the 4th.
Yeah, 3x.
So here's what you do. You just times the numbers in front. So that's like a 3 times a 1. It stays at 3. And then x squared times x squared is x to the 4th.
So the next one will be plus 20.
What? Oh, I'm going to go from the 3 again.
Oh.
So 3x squared times x squared, check. Now 3x squared times 4. What's that?
12
Plus or minus? Minus 12x squared. Next term, now I'm going from the negative 5 to the x squared. That's a minus 5x squared. And then what's negative 5 times negative 4? Plus 20. And you should have done that in Algebra 1, Algebra 2, Geometry, every math class ever. I can combine these guys. They're like terms. What's negative 12 minus 5 more?
8.
What? You borrow 12, then you borrow 5 more. Okay, very last row are all your little O's. Remember, that means you're plugging one function into the other function. So let's say I'm doing 25. I would do g of h of 3. And then remember, what I'm going to do is, I'm going to find h of 3 in here. And when I get that answer, I'm going to plug it into g. So let's find h of 3 first. Come up here to the top. H of 3, if I plug it in, it'd be 1 over 2 times 3 minus 5. What's 2 times 3?
6 minus 5.
Okay, what's 6 minus 5?
Then that just equals 1.
1 divided by 1, which is 1.
So you plug 1 into.
So then I want g of 1. So you find the middle function, plug into that one first, get your answer, and then that answer goes into the first function. So g of 1 would be 1 squared minus 4, which is 1 minus 4, which is negative 3. Okay, last one we'll do is g of h of 3. So g of h of 3. And then remember, I'm going to find this guy. Then when I get the answer, I'm going to go back and plug that into...
Hey, that's the same thing.
Yeah, skip it. It has been your face. Okay, we'll do 24 then. So f of g of 2.
2 squared minus 4.
So I'm going to find g of 2 first. Then when I get that result, I'm going to plug it into f. So let's find g of 2. So I'm going to come up to the top here. I want to know what g of 2 is. G of 2 is going to be 2 squared minus 4. But what's 2 squared? 4. And 4 minus 4 is... So my middle number there is a 0. And then I take that 0, I plug it into f. So I'd have f of 0 is 3 times 0 squared minus 5. But 0 squared is 0. 0 times 3 is still 0.
Are the same too.
Minus 5. Which ones?
22 and
22. Yeah, we crossed out 22. And then number 14, you see another little box. That's a multiply as well.
32.
All the boxes should be multiplies.
Alright, good.
Got it? So if you want to maybe mark it on here, 14, that should have been like a multiply. Alright, y'all have about 11 minutes or so. So get some work done. You'll have the answer key tomorrow to check if you need to. And then you'll have part 2 of your review. Anybody have homework for me to turn in?
Well, I got this review already.
Okay. Oh, I forgot. Yes, you can go. Sorry.
See, I told you to start with the work.
Bree, girl, give me that pen back.
See, look, it's not gonna work.
Thank you.
You can really tell.
16 marker.
It's 2 days.
So I'll give it back to you tomorrow. And then we'll have, tomorrow we're going to review all the graphing.
Put that button on. I'm gonna stay with one more thing.
You finished all of it, Colin?
I finished
Too
off.
good. Thank you.